Hello, everyone. Welcome to Pulling Back the Curtains on Packback's AI. I'm Craig Booth, going to be hosting this today. And honestly, I'm just so happy that I get to do this. It's the first time I've ever gotten the opportunity to talk about how our AI was designed. And I'm genuinely excited to get to share that with you. We have people gradually arriving, so I'm just going to start out with a little bit of housekeeping before we jump in. First, just so you all know, we'll send out a recording and a copy of the deck after this. We are scheduled for an hour, and we actually have Packback's CEO in the audience monitoring the chat. And so if there are any questions, she will flag them up to me. I'll be honest, I have to have the chat closed when I'm doing this sort of thing because I'm extremely easy to distract. So some questions will come to me live during this. I might be able to answer them, and we'll have time for Q&A at the end. So let's not hang around. Let's dive right on in. So the structure of this talk is as follows. I want to spend a little bit of time doing something of a opinionated and incomplete literature review on pedagogy. Because sort of the core thesis of everything that I want to talk about is that Packback's AI is powered by our ethical principles and pedagogy. So let's just start to normalize on like a few words and terms. They probably won't be new to you. I just like to cover them. Then also want to run through Packback's ethical principles, which are the other thing that go into powering our AI. And then with ethics and pedagogy out the way, I'm just going to dive into AI. And specifically, I'm going to give like a very high level introduction to AI with the hope being that we can give people some intuition about what AI actually is, and especially how it is applied to EdTech. Then I'm going to break out 4 different pieces of Packback's AI itself, coaching, originality, feedback, and grading, and talk about how ethics, pedagogy, and AI come together in those features. So just so you know a little bit about who I am. Hi, my name's Craig Booth. My background actually is in academia, got my PhD in high performance computing and astrophysics, did about a decade of research in galaxy formation around the world. And at some point realized that, what really motivates me and gets me out of bed in the morning is just building cool things and seeing them get into the hands of people. And that's honestly why I'm so excited to talk today. On the bottom here, I've just got a silly example of something that I built. This was around the dawn of generative AI, realized that I could train image generation models on my own face, and got an AI that, given me and the name of an artist, can generate a picture of me in the style of that artist, which, let me tell you, is hugely useful for generating up profile pictures. All right, so just as a reminder, Packback's AI built on a foundation of ethics and pedagogy. So the first 3 sections, ethics, pedagogy, AI. Let's dive on in. Packback has had an AI ethics policy for 6-7 years at this point, and it's a document that's only becoming more and more relevant as time goes on and the world catches up, essentially. So there is a well-known curve here called the Gartner hype cycle, which describes how new technologies are adopted. So on the left, things typically start here. Some innovation happens that triggers a bunch of excitement. There is then a peak of inflated expectations. And you can see right now, this is, I think, last year's hype cycle in AI. Generative AI is right up at this peak. Everyone's very excited about it. And typically, where technologies go is then everyone realizes all the things they can't do, feel disillusioned. And then over time, we hit sort of a middle ground with expectations where this is actually a productively used technology. But as of last year, and this is why ethics is so important right now, generative AI sits right at the top of here. And it's not something that people spend a lot of time thinking about. And I know a lot of people are very scared of, and I've just quoted from a paper here that it's very frequent for companies and users to neglect the ethical and societal drawbacks of AI systems. And this includes things like privacy, bias and discrimination, surveillance, and autonomy. So let's talk a bit about how Packback, I think about those things. So there are 5 keys in this ethics policy. And the first is that we are always going to prioritize the well-being of students above all else. And I sort of want to make a point here, which is maybe a slightly non-intuitive one, which is that algorithms are opinions. I think in a lot of people's heads, the word algorithm implies this very objective scientific thing. And I maybe want to challenge that being how we think about them. An algorithm is very much an opinion, just in code. When you're training some algorithm, you're choosing what data to feed to it. You're choosing what facets of that data to consider. You're choosing the range of possible outcomes. In short, like any AI system actually is an opinion, and we should have the reality of what we build reflect those opinions. And I don't want to ever lose that link between algorithm and what we are doing. So there we go. On to the next slide. So the next one is do no harm. Algorithms are opinions. Our opinions should be that we are reducing bias, considering worst case design, protecting data security and privacy. And this is an interesting time to be talking about this. On the right here, I just have a table of proposed and enacted state-level regulations on the governance of AI in consequential decisions. Consequential decisions are those that can have a big impact on someone's life. So health, finances, and education is in there too. And all of these bills are something that's very exciting for me because these are things that we've been planning for many years. The next thing is be a supplement for people, not a substitute. AI is really good at some things and really bad at others. We do not seek to replace anybody. We seek to augment them. And when you look at the word augment, when you look at its definition, it has two meanings. It can be to grow or to intensify. And if you think about the impact of a teacher on a classroom, there are two ways that we can help them. We can help them grow, by which I mean scale up to be able to teach larger classes at higher quality. So any tools we build might help someone grow. Or we might be able to intensify their ability to teach and let them give what they do best more directly one-on-one to more students. And probably my favorite example of this is actually this chart at the bottom right. This is the ELO ratings. Those are chess ratings of the best humans, machines, and cyborgs. So on here, an amateur is someone who's below 1,200. As we move to the right, the very best human player is Magnus Carlsen. He has an ELO rating of 2882. The very best machine player of chess at the moment is Komodo at 3393. The interesting thing here is the best chess players in the world are not humans. They're not AIs. They are humans and AIs working together. That's what cyborg means here. And uniformly, the best chess players are actually these cyborgs, where the AI explicitly augments the human and the human augments the AI. Next one, this is a big part of the core of this whole presentation. We need to be transparent and explainable in plain English. And I'm going to show this chart quite a few times. So I'm actually going to spend a minute to describe what's in here now so that I can do it quickly each time. This is a graph showing how complex an AI is. So on the left are very, very simple things. On the right are very, very complex things. And then the y-axis is showing how understandable they are by humans. So if you have a very simple AI, it's typically very easy to understand. If you have a very complex AI, it's typically very hard to understand. And our belief is that any AI that is making any sort of consequential decisions needs to be positioned very carefully on here so that those decisions can be backed up and audited to be free of bias. The last of these 5 pieces is be held accountable by humans. Not going to read out the policy here, but you might hear the phrase like human in the loop AI. That's not what we're talking about. I just pulled 3 random pictures from a paper here on human in the loop. This is the idea that you're training some AI model and humans get some input at some point. We actually mean something a little bit stronger. This is a quote from the EU's AI Act. What I actually mean here is human oversight. If we're making important decisions that could impact somebody's future, human oversight is how we minimize or zero out the risks related to that. So that brings us to the end of the ethics section of this. And as a reminder, I'm then going to do pedagogy, AI, and then talk about how those three things come together. But we prioritize the well-being of students above all else, be a supplement, not a substitute, do no harm, be transparent and explainable, and be held accountable by humans. And as I'm actually introducing the Packback AI, I will be jumping again and again and just mentioning these things so you can see how they get baked in there. So let's jump into pedagogy, an extremely brief, incomplete, chronological, and opinionated survey. So really, some of this stuff is not going to be news to anybody in the room. I just want to get it out there so that I can say the root words and just know that we all are working on the same vocabulary. So let's start all the way back in the 1950s, Bloom's taxonomy of cognition. One of the fun things I got the chance to do as part of writing this webinar is actually go back to all of the original sources to read about them. And the original source for Bloom's taxonomy of cognition is actually this, this handbook here. It's interesting to see how people talk about these things as they're actually working them out for the first time. And this is not a short book because their task was a big one. It was not classify different types of learning. It was build a taxonomy that describes all of learning. And they're aware that there are many arbitrary choices, like any decision you make like this is going to be completely arbitrary. And they built a model that is useful. And so what they found was that a possible hierarchy that describes all of learning, we really only see the 5 or 6 criteria nowadays, but this is actually sort of a deep hierarchy that goes down multiple levels in each of these categories, is that learning starts by remembering. In order to understand, you need to have remembered. In order to apply, you need to have understood. In order to analyze, apply, etc., 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 up to the top, which is genuine new creation. So in terms of tying this to AI, we've grayed out the bottom 2 here. These are things that are reasonably easy to teach at scale. Easy was the wrong word there. They're possible to teach at scale. If I want 1,000 people to remember something, I can probably just tell them. It gets much harder to scale the ability to teach people to evaluate and create. So when we're building, we probably want to be focusing up here most of the time. Next up, just continuing this chronological survey, mastery-based learning. And the original papers for this from the 1960s, maybe, actually describe a really interesting thought experiment, which is, imagine you had a group of students, all of whom have the same ability at something. So they're all 100% ability, but they have a different aptitude for learning or like to learn in different ways. If you apply one set of teaching to them, then the outcomes are just going to be dependent on the range of aptitudes for learning in that way. So if their students are distributed on a bell curve, you're just going to get a bell curve back out. And so the whole idea behind mastery learning here, which has become quite a standard thing, is really tune the teaching to the learner. So you do some instruction, you do a formative assessment. If the student passes, great, they go do an enrichment activity, they learn, are enriched even more. If they need to learn more, then you just do some more teaching that's more tailored to them, do a formative reassessment. And in this way, you can improve outcomes, which I actually show on the next slide. We're now firmly into the 1980s. This is the 2 sigma problem. So this chart on the right, again, is the original from the study. And this shows the student outcomes from 3 different ways of teaching a given challenge. So the first is a conventional 1 to 30 just lecture. If you swap doing the 1 to 30 lecture for doing mastery learning, you get an improvement in the student's grades. This is a better way of doing things. Great. But what they call the 2 sigma problem is that there is something better than mastery learning, and this is one-on-one tutorials. And the reason they call this a problem is at this point, they hadn't figured out any way of teaching at scale that could get the same outcomes as one-on-one tutorial. And to my mind, honestly, this result is one of the most marvelous and life-affirming results that there is. This tells you that given the right environment and teaching, almost every student can master what they're being taught. And I just think that's delightful. And what I hope to do with AI in my life is just anything that allows people to scale their ability to teach in a tutorial-like way. Next up, we're now moving into the 2000s. A lot of teaching happens online. What makes for a successful online environment? And there is Garrison's Communities of Inquiry here, which really says for a successful online learning experience, you require three things: a social presence, a cognitive presence, and a teaching presence. And those three things together, social presence meaning bonding with your peers, teaching presence meaning there is good design and facilitation of the learning, and cognitive presence is the extent to which learners are able to construct and confirm meaning through sustained reflection and discourse. That, again, when it comes to us building tools, if we are building tools that are in the online educational space, we should be aware of social presence, cognitive presence, and teaching presence. Continuing to move on. And again, I am going to come back and just summarize all of this on one chart, and I'm just sort of trying to level set with concepts at this point. Let's talk about intrinsic motivation and self-determination theory. So a student who is intrinsically motivated is somebody who is driven to do something because it's enjoyable or interesting, not internal rewards or pressures forcing them to do it. And on the left here, I just have a screenshot from a study that interviewed students about their levels of intrinsic and extrinsic motivation. First of all, verified that students who do not have much in the way of intrinsic motivation have significantly lower grades. And then also interviewed them about how they felt about a lot of their courses. And the students who have high intrinsic motivation are also people who are interested in and enjoying what they're doing. They're people who perceive that they are very competent at what they're doing. They're people who perceive that they have choice or agency in what they're doing. And they're people who can see how what they're doing is related to their life and to their goals. And this ties into a separate thing, which is self-determination theory. This is the idea that sort of fed into this study, which is that if you want to engage intrinsic motivation in somebody, you do it in three ways. You need to give them purpose by making sure that they can relate what they're doing to what they care about. You need to give them autonomy through agency and choice over what they do. And you need to make sure you're teaching them at a level that is related to where they're at. It's discouraging if something is too hard. It's boring if something is too easy. They need to be at a level where they can extract mastery. And I think there's one really neat example of this. This is just a fun study that I read recently, where students, this was actually adult students, teachers in this case, took a teaching course. And in this study, they were given an incredibly boring assignment to do. I think it was on correlation and causation. And the assignment was written in such a way as to be quite boring or non-exciting. And for the first set of learners, they just gave them this assignment. It was a 20-minute assignment, and looked at how engaged they were. They just used humans to visually assess how engaged the people looked. And what they found was during the first 10 minutes on this 0 to 7 scale, people looked about 5 out of 7 engaged. In the last 10 minutes, people looked about 3.8 out of 10 engaged. So the engagement falls off. Then in a second group of people, they actually just added the text on the right to the description of the exercise. And in this, it justifies that learning about correlations has been shown to be useful, that it will be useful for your job in teaching. It might not be fun, but we promise it's related to your life. And just by giving people those 2 paragraphs to read about how this work is related to their lives, they repeated this thing 20 minutes in a room, going to visually look at how engaged these people are. And they were significantly more engaged just by having these 2 paragraphs about relatedness. So that brings us to the end of the extremely incomplete literature survey of pedagogy that I want to talk about. And just to summarize everything, so on the left here, I've just made a diagram that's sort of a chaotic number of arrows whirling around, but we have Bloom's taxonomy, mastery-based learning, the 2 sigma problem, communities of inquiry, intrinsic, extrinsic motivation, and self-determination theory. There's a lot going on there. But the way I think about it when we're designing AI is that we really want to achieve three things in everything that we do. So the first is we want to be giving mastery-based feedback. We want to be connecting what we do to a student's purpose. And we want to be giving the students autonomy and trust. So if I had to boil these things down, the things on the left, I would say those are the three things that we really care about doing with AI, in addition to the ethical things that I already mentioned. So at this point, I just have one slide because I don't know what fraction of the people in the world in the room use the Packback platform. I just want to quickly say what our platform is. It contains three main products. The two that I really want to talk about today are discussions and writing and originality. Discussions through Packback Questions is an inquiry-driven discussion platform where the students are empowered to ask the questions. And so begin to think here of thoughts of self-determination theory, think of the social presence from a community of inquiry. And then Packback Deep Dives is a long-form writing product, a writing assistant, a research assistant, a grading assistant, and begin to think mastery-based learning, our ethical commitment to help scale good teaching and grading. And so these three products, they have slightly different purposes, but they all do the same things with AI. There are some key AI workflows. And those are that we give students rapid feedback on what they're doing. We give digital grading assistance to educators to help them scale. And we have academic integrity workflows, which I'm going to touch on at the very end of this webinar. All right, so that wraps up pedagogy. We've covered ethics, pedagogy. The third thing I said we were going to cover is AI. So I'm going to start with what is AI and then go on to what is Packback's AI. So what is AI? The probably best description of AI I've ever read is also the simplest one, which is just AI is when computers do things that mimic human intelligence. That's it. That's the whole definition. You don't need to know any more or any less than that. So that means, is playing chess AI? Yes. Is translating text AI? Yes. Plotting a route on a map, recognizing a face, writing a blog post, drawing a picture, grading an essay, giving feedback on writing, moderating content, all of these things, these are all AI. But you might notice there's like a wide variety of things in here. Like solving playing chess is a much different problem than writing a blog post or drawing a picture or recognizing a face. So this should begin to indicate to you that AI is not one thing, right? AI is a lot of things. It's a lot of different techniques that solve different problems in different ways. And I do think it's useful to go one step further than this and begin to crack open what do we actually mean by AI. And there are very many different types of AI. I'm going to pull out 4 types right now: machine learning, deep learning, expert systems, and generative AI. And I'm going to go from simple to complex. And my goal in these slides is not to teach you the details of AI, but to give you a flavor and an intuition for how each of these things work. So the way I think about this is there is this whole field of AI, the big blue circle on the right. A subset of AI, one of the things that's in there is machine learning. A subset of machine learning, one of the things that's in there is deep learning. A subset of deep learning is generative AI. And then kind of off to the side, we have expert systems. So again, I'm going to go simple to complex. Let's start by talking about expert systems. And expert systems are essentially systems where rules that are known by humans are codified into decision trees. And you see these quite frequently in the world, and for example, medical diagnostic tools, chess playing robots. And I have an example at the bottom left here. This is a simple decision tree for estimating what interest rate you should give somebody who wants to buy a car. And first, we have encoded in here, check their credit score. If it's greater than 800, follow the top branch. If it's less than, the font is very small on my screen, less than whatever that number is, follow the bottom branch. Then look at what fraction of the car payment, what fraction of their income the car payment represents. Is it a high amount? Is it a low amount? And then just by following a couple of these branches, you will get to what acceptable interest rates look like. And this is a very, very simple example of a decision tree. A more complex one might be, and this is one of my favorite examples, I worked on it in a previous job. It used to be the case that in passenger airlines, there would be a book, just a hardcover book in the cockpit with the pilots. And the book was essentially a giant decision tree. If red light X goes off, check dial Y. If dial Y is greater than 500, go to pay. It's like a choose your own adventure book, right? It's a giant expert system decision tree. And as far as I know, I don't know if the books are widely used anymore. I would imagine they're still in the cockpits in case the computer breaks, but decision trees can be incredibly useful things. And again, they're used a lot in the medical space for doctors to navigate down trees of symptoms to get to possible diagnoses. All right, moving on from expert systems to which are sort of sit on their own off on the side in all of this. We're coming to machine learning. So machine learning is a subset of artificial intelligence, and it is the type of AI that allows computers to learn and improve from data without being explicitly programmed. So what I mean by this is they're essentially just statistical models on the whole. So I have some known data, and just to pick a dumb example from thin air, I have 1,000 pictures that have dogs in them and 1,000 pictures that don't have dogs in them. I have some algorithm, and I'm going to feed all 2,000 pictures to that algorithm and say, this box of pictures has dogs, this box does not. The algorithm is going to chug away for a few minutes, hours, or days, and then say, ding, I'm ready to go. And at that point, I can throw new data, a new picture, and the model can estimate, given the pictures it's seen in the past, whether or not there's a dog. So typically when you hear machine learning, you're thinking about models that can make predictions or classify things. You know, what is the percentage probability that there is a dog in this picture? Might be a thing that a machine learning algorithm does, for example. And machine learning, even simple machine learning, is a little bit harder for a human to understand than the expert systems that we mentioned before. So let's go one level deeper. Let's go to deep learning. Deep learning is a subset of machine learning that uses artificial neural networks to teach computers to process data and make decisions based on examples. So deep learning is machine learning, right? It has the same purpose. It's an algorithm that you can feed data into, and it can learn how to make predictions. The main difference here is just it's a type of machine learning, and it's a type of machine learning based on neural networks. So if you imagine a human brain is full of neurons that are connected together, something happens and electrical signals go flying through the brain, and the pathways that get used a lot get stronger, the pathways that don't get used get weaker, ... humans happen, all animals happen. And deep learning is essentially an attempt to do the same inside of the computer. You model a bunch of neurons, you throw a bunch of data in, you give it a challenge, classify this picture or whatever, and then gradually over time, some of the neurons will connect strongly, some will connect weakly, and you'll end up with a neural network that can predict whether or not there is a dog in that picture. This is more complex on the whole than most machine learning algorithms, but also works better. So then let's finish up with generative AI. It's a subset of deep learning, and it refers to models that can take raw data, like all of Wikipedia, and learn to generate statistically probable outputs when prompted. And that brings us to the end of sort of the AI section here. So on the right, we've got this picture. Hopefully now everything in here just makes pretty intuitive sense to you. And on the left, we've got the understandability complexity thing that I showed you earlier. So on the left, you've got simple algorithms, probably expert systems. As we move to the right through machine learning, deep learning, generative AI, sits somewhere off the right of that picture. And I think this was an interesting LinkedIn post from a few days ago, which is something did change with generative AI. It is so much more performant and scary than the rest of AI. I just want to take a second to differentiate it. And I think in most conversations, it's generally a good thing to separate out machine learning and deep learning, making predictions, classifying things, from generative AI, which is this AI that is creating. So I just want everyone to be aware of that difference. And when you hear the one phrase AI, it actually means quite a lot of different things. So this brings us into talking about Packback's AI. It does three things. I don't really want to talk about it in too much detail right now. I'm going to be hitting on each of these things separately. but it's feedback, coaching and tutoring, and moderation and grading. And like I did with AI, I actually want to maybe talk a bit about how to conceive of Packback's AI. If you say the AI, what pops into most people's minds is like a singular AI brain. Packback's AI is not that. Packback's AI is an entire network of brains communicating. It's 50 plus different algorithms from all across the space of what you can do with AI, chosen to support our pedagogical and ethical needs. So when someone says the AI, it's like the intuitive thing is to think of it as a monolithic singular thing. It isn't. It's a lot of things. So our challenge as an AI company is actually to figure out how to use the best tool for every job. Like the tool I want to use in tutoring a student is different than the tool I want to use in assessing them or in moderating them. And so our job is to use the best tool for every situation. So I'm not going to go into this. On the left, this is just a schematic I use to talk about Packback's AI. But if you ask me a question about Packback's AI, the answer I give you will almost certainly be yes, every single time. So is Packback's AI machine learning? Yes. Generative AI? Yes. Natural language processing? Yes. Expert systems? Yes. Statistical or analytical models? Yes. So again, this is sometimes sort of a different way for people to think about AI. We are going to be choosing the best tool from the job. And I just want to harp on this for 1 second. What does best mean? Best just doesn't mean like biggest or most complex. What we are always doing in every application that we have is assessing our AI capabilities in 3 ways. First of all, there is the more complex algorithms typically work better. So the one part of it is we want to do as well as we can. But this is bounded by our ethical policies. Should we be using data in this way? Do we want to use generative AI here when we can't open up the box and see what's inside? And also by our knowledge about pedagogy. Is this the right thing to be doing? Even if the coolest algorithm in the world exists, do we want to use it here because it's not good pedagogical practice? So I'm about to start diving into the aspects of Packback's AI, and I really hope everyone can just have this in mind. It's ethics, pedagogy, and algorithms all together are what make up Packback's AI. With that, I'm just going to have a drink of water and dive into talking about, there are 4 different sections here. We've got grading, we've got feedback, and we've got tutoring, and then a quick note on originality. So let's start by talking about grading. Grading is probably the single place in the platform where this curve on the left is the most influential. If we are using an algorithm to assess a student's performance, that is a consequential decision about their life. We could change their employment prospects based on the output of this model. And what that means is we just have to jam all of the models that are related to grading as far to the left on here as we can. And there is a whole field of research related to this called XAI. This is explainable AI, which is really about how can we take a model and explain it? And the reasons to explain it are to justify decisions. Like we should be able to look at a model and say, this is why we did this. To allow people to trust in the models, to improve systems and control errors, and to be able to look at the model and learn from it. Like if I give you some black box model and it says, there is a picture of a dog here, it can't explain why it believes that. And that makes it inherently a dangerous thing to use in any sort of high stakes situation. So when it comes to grading, just think we have to jam ourselves all the way onto the left of this chart. And just to give you another few examples of sort of interpretability and bias, here are a couple of models that are extremely interpretable. I'll be honest, I don't know how biased they are. So on the left is a simplified credit scoring model. So this really just says, we're going to look at your payment history, and we're going to see the number of months since you have a derogatory public record. Given these numbers, you get this many points. We'll look at outstanding debt, credit history level, pursuit of the new credit, credit mix. We'll just add these up and get you to a score. Now, like I said, I'm not qualified to say whether this is biased. I don't understand much about finance, if I'm honest. Do some of these things discriminate against certain groups? Maybe, I don't know. But I can look in the model and at least begin to figure that out. And I'm sure experts can figure it out. The thing on the right is exactly the same. This is our car loan interest rate calculator. Again, it's simple, explainable. If somebody says, why did you offer me 6%? We can actually just turn back around and say, we offered you 6% because of your credit score and because of your income to debt ratio. A final example of this, you can use these across the board. This is a simple model that can actually tell you what type of iris you're looking at. Is it iris virginica, iris setosa, iris versicolor? And you can do that based on simple decisions on the width and length of petals. So that, when I'm talking about being like jammed hard left on the complexity scale, this is the sort of thing I'm talking about. But I now want to justify when we might want to move away from the left-hand side of that. And we've just talked about flowers, let's talk about Netflix for a while. Back in 2009, Netflix ran $1 million challenge. Netflix had an algorithm that was able to predict to within half a star, 75% of the time, how I would rate a movie that came out, given all of the other ratings that I've given, all of the other things I've watched all the way through. And Netflix put out a challenge. They did it once in 2006, once in 2009, and just said, we'll give you $1 million if you can make this algorithm better. And on the right here, I've got this is a histogram showing the results that came from that challenge. So this is just a cumulative number. So 50% of the algorithms that were submitted were able to improve the Netflix score by 7.7%. And the very best one was able to improve the cinematch accuracy by 10%. And I just want to underline what went into achieving that. It was more than 2,000 hours of work, and it was 107 algorithms combined that gave them this prize. And, what does this mean? Like, when it comes to grading, it means we don't touch this. We don't touch this with a 1,000-foot pole, right? This is not something that you can explain. But in this case, for predicting stars on Netflix movies, do I care if I can't explain it? Probably not in that case, but that's a choice, a trade-off, an opinion that I have to make. And now, just before moving on, I just have one sort of fun thing here. In part of my other life, I do a lot of security and compliance work, and was writing a presentation on that, specifically on something called SOC 2, which is Service Organization Controls. It's just a big, tedious audit. And I wanted a piece of clip art to put in a slide, and I just went to an AI-generated image detector and just said, imagine SOC 2. And what came back was a picture of a Gothic bird. And I was like, that's strange. Did it 15 more times, and I got back 15 more pictures of Gothic birds. I was like, well, this is weird. Maybe there's a character somewhere called SOC 2. I just tried SOC 3. What came back when I did SOC 3 was like a bunch of like fantasy forests and gnome villages. So can anybody in the world explain to me why SOC 2 is a goth bird and SOC 3 is a gnome village? The answer to that is no. And again, in this case, do I care? Probably not. It's amusing. It doesn't matter. But if we look at what best means in the context of grading, what it means is we want to be all the way on the left here. We want to be doing things that look like decision trees and expert systems. We do not want to go over into Netflix territory, or worse of all, generative AI territory or gnome forest territory, which is all the way off on the right here. So I've now, just to wrap up this first of the 3 sections on the Packback AI, just have 2 slides showing what this looks like in the Packback platform. So Packback does assist with grading. I say assist, there is always a human moderating this. This is whoever is doing the grading. But the things that we auto-grade on are all extremely interpretable and extremely reliable. So if a student in Florida and a student in California write the same essay, they are going to get the same score. That's it, 100% of the time, that's just how it works. If you want to open up the algorithms and understand how they work and how we arrived at them, they you can. We will never have a black box do grading. So this on the right here now is the 5 criteria that the Packback platform will auto-grade on: word count and depth, grammar and mechanics, flow and structure, research quality, and formatting. A lot of the time people want AI to feel magical, and this is one place where it might feel magical, but it just isn't, right? This is extremely mechanical and reproducible. The actual magic that happens during grading is just in this bottom number here, ideas and content. And this is the bit that humans are good at, right? To read an essay and understand it and assess it against its criteria, and that is what humans are good at. So in this way, we are able to assist and help. So moving on now from grading to feedback. Feedback is an interesting thing. And the more I dove into the literature on feedback over the years, the more I realized just how hard it is to do. And I've got a couple of quotes from papers here. These both come out of this Kluger and Denisi paper. But to relate feedback directly to behavior is very confusing. Results are contradictory and seldom straightforward. And on the right, feedback does not uniformly improve performance. There are ways to give bad feedback. And in this particular paper, I just like this one quite a lot because they looked at a lot of things. So don't worry too much about the thing on the left. This is just 36 different ways of giving feedback. To summarize it, there are some things that help, some things that hurt. And in a recent review on formative feedback, here are 9 principles for giving good feedback, another 9 principles for things to avoid. I'm going to keep moving right now to talk a bit more about the Packback platform, but then I'm going to tie that back to these 18 criteria. We had some optional stuff. So just in case people haven't seen the Packback platform before, this is how we do feedback. So on the left here is a student working on some work. On the right, we give feedback using some of these 50+ AI models. And you'll notice this is feedback that's given very quickly. As a student is making changes, they are getting changed, improved feedback very quickly. You'll notice it's very factual. You'll notice it's very short and to the point. So that is what our feedback looks like. How does this tie to some of the best practices? The first is, I skipped over this slide just because we're running a little bit behind, but the feedback focuses the learner on the task, not on a grade or on their peers. We try to be as specific and clear with feedback messages as possible. We give unbiased or objective feedback and give it via computer, which it turns out is actually a good way to give feedback. We specifically never give normative comparisons. We don't compare a student to their peers. We are extremely cautious. We don't provide overall grades when we're doing this. We will never discourage a learner. We will not interrupt a learner if they're actively working. And then one of the most interesting ones is, one of the best ways to give feedback is to provide elaborated feedback to enhance learning. And I want to dive for 1 second into how we do that before wrapping up with a bit about coaching and tutoring, and that should bring us in about on time. So on the right here, I just found an example essay on the internet, put it into Packback, and it's just highlighted a few problems. If you click on any of these problems, what will pop up? Oh, we lost a picture, but what will pop up is a brief description of the feedback. In this case, it will say, the learn does not appear to be grammatically correct. And a button saying, explain this to me, which will elaborate the feedback. So here, for example, this is when I did this. It elaborated the feedback. I still didn't quite get it. So I just asked, why is the learn not grammatically correct? And the AI elaborated. So this is the first place you've seen me talk about using generative AI or large language models inside of our platform. And again, that's because we use them in very limited and confined ways, which actually brings us straight in to talking about coaching and tutoring. So I think it's a really good question to ask. Does generative AI help or hurt learning? And there's actually a pretty robust literature on that at the moment. And the answer is yes. So as a reminder, we are looking now at the very small white thing in here, the very most complex type of AI. The answer is yes, it can help and it can hurt. So here are 3 papers on this. I'm going to pull one result out of one of them. They're all phrased in the negative, like when does GPT harm learning? Generative AI can harm learning, but it turns out it can help. And in some of these experiments, what the authors did was they gave students access to an LLM to ask questions to. And one version of the LLM that they call the base is just a standard large language model. If you go to openai.com, sign up, this is what you get. And here, so this is the question. It's about mapping 2 formulae onto one another. If you ask what is the answer, it answers. That's what it does. Those students do perform better on practice problems for some reason when given access to GPT. And the reason, obviously, is you can ask for the answer. But those students, when you take GPT access away and you do a closed book exam, they struggle greatly. But that is not true if you use AI in a different way. So in the bottom here, the authors have shown us an AI tutor. So here you see the AI introduces itself. You ask it what is the answer, and it will say, I'm afraid I can't do that for you. It's important for you to work through the details. And in this case, these students still do better on the formative assessments, and there is no degradation of their performance on the summative assessments. And there are other studies that actually go even further and say AI tutoring can outperform active learning in some contexts. So on the right here, so on the left, I've got just the graph from the 2 sigma problem, which might be in your minds at this point. But this is student surveys of their knowledge of a certain thing prior to a lecture, and then either after a lecture or after interacting with an AI tutor. So there is some evidence, at least this one time, that an AI tutor can actually, begin to look a lot like something from the 2 sigma problem, that we can begin to approximate one-on-one tutoring in some way. And what does that look like in the Packback platform? We actually have a series of writing tutors that are completely aligned to all of this research. So this is just a screenshot from the platform. On the left is some essay I wrote about Leonardo da Vinci. And then there's a chat tab, and we have a handful of very, very focused AI bots that will help you in very, very focused ways and act as tutors, exactly like in the studies that we just looked at. So here's an example on the right. So I asked it to help me write through writer's block. You'll see at the end, I just started up with write it for me. Could you give me an example? And it refused to do it. So these are guided chat experiences. They're not just open-ended LLM chats that students can interact with. It's protected by a lot of internal moderators. So the AI should always refuse to write for the student, refuse to say any derogatory things about anything at all. It will add a warning if it looks like it might be about to say some factual information to tell the student to go and verify this. But in summary here, the Packback platform uses LLMs in the targeted and limited way that has been proved to help students. And so I'm just coming into the last 3 or 4 slides at this point. And I just want to talk a little bit about originality, and specifically about originality in a world where generative AI exists. And one thing that I think that's easy to miss on a day-to-day basis is how groundbreaking, ground-shaking, earth-shaking this is. This is a screenshot from a paper about how rapidly various technologies have been adopted. So the red curve is how long it took to adopt home computers after the first one was released. And after 3 years, 20% of people had interacted with one. After 8 years, that number was 33% or so. And after 22 years, it was 70% of people had interacted with a computer. The internet was adopted somewhat more quickly. This is both of the green curves. AI has only been out for a couple of years, but is going to breeze past all of these things. So I think the thing to take away here is generative AI is already ubiquitous, and it's going to be completely ubiquitous. And that does give us a problem in a world where traditionally people have worried about plagiarism. And plagiarism used to be something that was extremely well defined. As in, if you copy paste something and don't cite it, that is plagiarism. If you paraphrase somebody else's idea and don't cite it, that is plagiarism. The definition has gotten much more fuzzy. And just some numbers on this. This comes from a company called Turnitin, who you might know. They analyzed 38.5 million submissions. And they found last year that about 10% of those submissions contained over 20% of text that was likely produced by AI writing tools. So just in summary here, this is going to be ubiquitous and transformative. On the right here, I have, this is from the Harvard College Writing Program, their guidance on how to design assignments that are perfect for working with alongside AI. And honestly, I would love to spend a lot of time talking about AI-generated text detection originality, what it means for grading and grading the process over the product. But I don't have time today, so I'm going to drop with one little advertisement. This is the first in a series of 2 webinars about Packback's artificial intelligence. And it's titled Originality Fingerprint, Packback's new advanced plagiarism prevention and detection solution. And in there, this is going to be myself, Kelsey Beringer, Packback's CEO, and Jess Tenuta, Packback's Chief Product Officer. We'll talk about originality. We will go into more detail about how AI changed the narrative around academic honesty. We'll talk about plagiarism prevention as opposed to detection, and what's next for education. So with that, I've gotten to the end of my prepared comments. Kelsey has flagged up a couple of questions that have been asked. And so I'm going to address those now. If anyone else has any more questions, throw them into the Q&A and Kelsey will send them my way. So the first question was, why would an assignment written by AI not be flagged as written by AI? This is very relevant to what we've just been talking about. And this, to be clear, we're about to have a whole webinar on this, but I think the answer is actually a really interesting one. If you look at the inner workings of every single AI-generated text detector, they're all pretty much the same. They are a statistical fingerprint, nothing else. The owners of those models, and this includes Packback, we've built one as part of our platform, generated up a lot of AI-generated text and trained a machine learning model that can classify, this is probably AI generated, this is not. And any statistical model can be wrong sometimes. So you need to make a conscious decision about how wrong you're willing to be. So for example, on the Packback platform, we tuned our model, but assuming that we do not want to make a false accusation of plagiarism against a student. And we tuned it so that our false positive rate is 0.0007%. What that means is we are going to miss some AI-generated text on the platform. But that, to me, is preferable to falsely accusing students of plagiarism. And this is true of every single AI-generated text detection model on the market. Everyone has to make a decision about a false positive rate that they think is acceptable. And my big takeaway here is originality is not just this one thing, right? It's a much, much larger question. It shouldn't just be, do I have this statistical fingerprint that AI might have been used here? If we can get insight into the student's writing process, if we can compare their writing to other things they've written, if we can check plagiarism against other sources of things on the internet, this is all part of a story. And what we want to be doing is telling that story. AI-generated text detection on its own is, quite frankly, a losing battle. And it's something that is inherently, in the language of this webinar, unexplainable. And then let me see, the second one is, have you found that some students seem to feel that their autonomy is threatened when they learn that AI is being used in their grading? Is fear of loss of autonomy what's going on? How do you work to help them overcome that? And that's a great question. And I think the answer is transparency. I think, one second, I'm just going to find a screenshot of the platform. Here we go. I think if you say with no further context, AI is being used in grading, that lets people's minds run absolutely wild. What is the AI doing? Is this a large language model writing a criticism of my writing? Am I fundamentally empowered here? if you look at this through the lens of Packback, AI grading is not something that strips autonomy in any way. In fact, all it does is makes the professor's life easier by taking care of the routine and mechanical stuff that they need to do. So if I were hearing that concern, first of all, if I were a professor hearing that concern, I would raise that with my contacts inside of Packback. We have an extremely strong answer to that and can help you craft it. And it is that the AI is just doing the boring mechanical stuff. You are being graded by a human. We are just helping that human be more effective. And with that, that actually brings us, we still have a few more minutes, but no more questions have been raised to me. So I'm going to call this here. Thank you so much, everybody. I genuinely am grateful to every single person who's here. This is something that I care about deeply. If there were any questions that didn't make their way to me in a different window, we will follow up on them asynchronously, probably just by writing out all of the answers as a blog post. Again, the slides and recording are going to go out to all of you. I hope in some way this was useful or interesting. And if you are left with lingering questions, please just reach out to your Packback contact and they can send those questions directly to me. So thank you so much.